Now we have a capacitor, and notice how I've put it in with the leads kind of hanging off. All right, we'll take another thing, and now we see that the impedance going down with frequency, right? But there's a resonance, and so we see an inductor in there where the impedance is going high. All right, we can find out where that is, right? And interestingly, at that point, right, if we look at it, the resistance is 1 ohm. So it actually takes a sophisticated instrument to be able to supply enough current and, you know, average out the noise. I tried to make a homemade one with just an oscilloscope, and let's just say I was having trouble making my impedance analyzer work. All right, let's go calculate some parameters, right? B, negative. Really, D looks more like a capacitor. Okay. 12 nanofarads. All right, I can try E. Yeah, it's a little more accurate. Okay. But now just remember this number. Well, I want to go back to D and calculate. So we have 27 nanohenries, right? So now go back and get rid of the leads, if you will, by sinking it in there, retightening, and you should see that move. See, the point at which the impedance goes up shifted to the right, therefore the inductance should be lower. Let's calculate it. And we went from 30 to 5. All right, and so yeah, when you're doing things on a PCB board or even those push and pull things, yeah, the leads can have a significant effect. All right, now what frequency are we at? By the time this starts to happen, let me just double check. 20 megahertz. Okay, that's where that would start to have a point. So, you know, 97, yeah, we keep the frequencies lower so that we're not seeing these parasitic effects. But again, you can take these equivalent circuits and put them into LT-Spice and have a more accurate picture of what's going on with your passive device. And you know, different capacitor, resistor, inductor structures have different parasitic values, and some are good for some things. That's why there's a lot of variety. But a capacitor is not, you know, they're not all created equal. All right, and then we'll finish up with a resistor.